All right. 8.5. We are solving. Remember, I mean, in like every chapter we've had, we've like done simplifying, solving, and graphing in some kind of order. In this one, we started with graphing. Now we've been simplifying, and now we're going to solve them. So in solving, we're always trying to find x. X. Or whatever variable they give you. So here we are going to, our first step, because we're trying to find that x and that exponent, which is kind of complicated. So we're going to use logs to our advantage. So we're going to log both sides. So log of 7 to the 3x equals log 20. What's my base in these? 10. Okay, if you're having to create your own log, usually going with 10 is the best bet. All right, from here, how can I simplify?
Couldn't you move the 3x to the front?
Yes, through the power rule, I'm going to move 3x to the front. So I have 3x log 7 equals log 20. And I'm trying to get x by itself. So it's all multiplication over there by x, right? Yeah? Yeah, okay. Yes, sure, Coach Kyle. Okay, so I'm going to divide everything else out. I'm going to divide the 3 and the log 7 to the other side. It all cancels over there. And I just have the x equals log 20 over 3 log 7. We're going for decimals in this lesson. Decimals, not decibels. All right, decimals. So put that in your calculator. Make sure it's obvious that the 3 log 7 is all on the denominator. And round to 4 decimals and tell me what you get.
0.3665.
Okay, you should have gotten 0.5132. Whoa! What in the world? 0.5132. I have no idea what that is. Okay, let's do the next one. It's same strategy. Okay, so we're gonna log both sides. So it's gonna be log 3 to the x plus 4 equals log 101. All right, what can we do? We're going to move it to the front, and that's all one piece, so we need it in parentheses up there. X plus 4, log 3 equals log 101. And just think about this, that we're trying to get x by itself. So we can't pull it all at one time like we did before. We can't divide by everything at one time. So what's the farthest thing from x that we can go ahead and get rid of? The log 3 is correct. So we're going to divide by log 3. Divide by log 3. All right, so now what we're left with is that this is gone. So we just have x plus 4 equals log 101 log 3. So, yes. So next step is to subtract 4 from both sides. So we get x equals log 101 divided by log 3, all minus 4. So this is the point where you put it in your calculator, and it tells you. Mm-hmm. So what did you get for the 4 decimals? 0.2009. Okay, perfect. Yes, that is the right one. Yay! Now we're going to use our calculators to solve this by graphing. Any idea how we would solve this by graphing? Yes, Cooper's on it. Put this one in y1. Put this one in y2, and what do you need to find? The intersection, the x of the intersection. And we already said y2 equals 1500, so your y max needs to be bigger than that. So make the y max like 2000. In window, and then it'll say y max, and in that one type in 2000. And you can round to 4 decimal places again. What did you get to 4 decimal places? 8. All right. Who needs help? So now we'll still use the calculator, but we're not graphing for a minute. We're going to, our goal, too many words at one time. Okay, our goal is to convert log base 3 of 15 to a log in base 2. So we want that 3 to become a 2. But we don't know what's going to go instead of the 15. Okay, so that's what we're trying to figure out. What's helpful is that we have this change of base formula. Okay, we can have log base a of x and make that equal log base b. B can be whatever we want, but we're going to make it something specific, of x over log base b of a. Okay, so the x went there, the a went there. All right, so we're going to use that formula to start out with. But what is weird, but I promise, just trust me, we're not going to put it in base 2 yet. We're going to put it in a base that we can work with in the calculator, which is base what? 10. Okay, so we're going to say that log base 3 of 15 equals log base 10 of what goes on top? The 15, and then on bottom log base 10 of what? 3.
Do you have to put the base 10?
No, I was just writing that so it was clear. That's what we were using. If you know that's what it is, you don't have to write it. Okay, so now use your calculator to figure out what that ratio is, what that fraction is. Log base 10, log 15 over log 3. And we'll write it down. What'd y'all get? It should start with a 2.
2.465.
Okay, we'll just go with 2.465. Okay, so we got that. Now we're going to write our equation of what we're trying to figure out. So we're trying to get log base 3 of 15 into something that's log base 2 of we don't know, so we're going to put an x. Okay, that's our goal, to get it into this log base 2. So we're going to substitute what we know log base 3 of 15 equals. Well, that's the decimal you just figured out. So we're going to write that 2.465 equals log base 2 of x. All right. Next step is to write it in exponential form. So if you remember, we're going from y equals b to the x. Or actually, that's what we're ending up with. We're starting with log base b of y equals x. So what's my y going to be? X is correct. Okay, so we're going from here to here, and it's confusing because we're using x, but that's okay. Equals, what's my base? 2, and so our exponent will be 2.465. Use your calculator again to figure that out. So just put 2 to the 2.465. Tell me what x equals.
5.5213.
Very good. So we found x, but that's not what it asked us for. It asked us for the whole log in base 2. So we're going to write it out. We're going to say log base 2 of 5.5213. Ta-da! Okay, so we're solving log equations, and we can do it by math or by graphing. So I'm going to show you the math way first, and then we'll graph it. And you can, I think on your homework, it lets you choose which way to do it. Okay, so mathematically, we're starting with log of 3x plus 1 equals 5. What is the base? Here. 10. Okay, so let's make, well, actually, let me ask you, what do you think we should do first?
You should make both.
Like go outside. Should you distribute the log into both numbers?
We
Should
can't
you pull the
do that.
3x plus 1 on the other side? Oh, never mind.
No.
Subtract by it.
No. Can we get rid of the log somehow?
Inverse?
Divide it.
Huh? Close. No, can't divide it. It'd still be there on one side. How about just putting an exponential form? What we just did. Okay, so what is my base going to be? 10. Okay, what's my exponent going to be? 5. My exponent is 5, and that equals the y, which was 3x plus 1. Hey, what's 10 to the 5th?
Like 100,000.
Yeah, I think 100,000 is right. Yes, it's got 5 zeros. So that equals 3x plus 1. Now what? Subtract 1, so we get 99,999 equals 3x. Now what? Divide by 3, divide by 3. So x equals?
33,333.
Yep. That would be our answer. That's what that x equals. Wouldn't have guessed that, would you? That was what goes right there? With all those simple numbers.
Well, you know what? That's just.
Okay,
Yeah,
so
that's math. Okay, yeah, so let's do the graphing. We're going to do it the same way we did the other ones, where we have y1 and y2. So write down your equation. Log of 3x plus 1. Sorry. Got a little ahead. Because this, what's the base here? We already said it, 10. Okay, because it's what we can do with our calculator, we can graph this. You'll put this side in y1, this side in y2, and find the intersection, just like we did on the front.
I think I like that.
Okay.
So do you put the log into the graph?
Mm-hmm. Let's think about this. What did we get for the x on the other one? I mean, when we did it by hand?
3.
A really big number, right? So to see that number on your graph, you are going to have to make your x max bigger than that. So like 40,000 or something. Something crazy. That's a disadvantage of doing it by graphing, is that sometimes the numbers are going to be huge and you have to guess. We didn't have to guess on this one because we did it by hand first. Okay, so that's kind of the disadvantage. But you should be able to get that the x was still the same, 33,330.